Hey there, this is a video for my 40S Pre-Cal students. This is going to be a 4.4 video, and I know that there is already a video for 4.4 on the school's website. Miss Cox's video is perfectly good, but I'm going to go a little slower, and she gets through some of the examples and then she ends off by saying you should try some of these on your own. So I'm going to do them a little more deliberately, and I'm going to go through all of them. So this will be kind of a longer video. Feel free to fast forward through parts of it if you're feeling confident that you know what's going on. All right, let's get started. We have to solve this equation algebraically. Now, to me, there's no real difference between this algebraically between this equation and just 2x minus 3 equals -1. I'm going to solve that by adding 3 to both sides and then dividing both sides by 2. Only now, when I do that, my x is actually a cosine of theta. So 2 cosine of theta is equal to -1 plus 3, and the cosine of theta is equal to 1. Now, where on my unit circle, all of the ones on this first page are all unit circle, no calculators. Where in the unit circle do I have a cosine value of 1? So I would actually maybe draw myself a little unit circle, and remember that cosines are the x values, and that happens right here at 1, 0, which is of course at 0 degrees. Now I know I'm looking for a degree answer because this domain is in degrees. So it will happen at 0 degrees, and then it'll happen when I go all the way around at 360 degrees. And you might think, well, that's it, right? But actually it says, no, keep going until you get, ooh, careful, less than 540 degrees. Well, if I go all the way around again, that would be 720 degrees. And I actually don't hit a 1 for cosine between here and one more time around. So that is it. That's the only two answers I have. Okay, so you got to make sure you watch carefully what the domain is asking for. All right, next one's a secant problem. Once again, I'm going to use some algebra. So 4 times the secant of x is equal to -8. So that means the secant of x is equal to -8 over 4. The secant of x is then -2. And I don't know much about secant, so I'm going to reciprocal both sides of this equation. So that's going to then be the reciprocal of secant is cosine, and the reciprocal of -2 is -1/2. All right, now I'm in radians. How many places in radians, or how many places on the unit circle, counting them in radians, does cosine make -1/2? Okay, well, cosine is a half in the pi by 3 family. In the pi by 3 family, it's √3 over, it's 1/2 comma √3 over 2, and cosine is the 1/2. So where is cosine -1/2? Well, cosine would be -1/2 in this quadrant, and so that would be 1 pi by 3, 2 pi by 3, so x is equal to 2 pi by 3. And then cosine would be negative in this quadrant, which is, think about it, that's 1 pi by 3, 2 pi by 3, 3 pi by 3. Here would be 4 pi by 3. So there's my two answers for that one. And you should underline your answers or put a box around them or something. When I'm looking at people's work on a test, I need to be able to find the answers quickly and efficiently. Okay, now we're going to get to ones that are quadratic. All right, let's try a quadratic. Well, this is an easy one to factor. I'm just going to factor out the sine of x from here. When I factor sine of x out of sine squared of x, I get sine x, and when you factor something out of itself, you get 1. All right, so that means there's two solutions. This can be 0 or this can be 0. So if the sine of x is equal to 0, let's see, where does that happen in degrees from 0 to 180? Well, sine is 0, that's the y is 0. Here it's 0 degrees, and again at 180 degrees. So again, those are both equal to's. So there's two answers there. X can be 0 degrees, or it can be 180 degrees. It would actually hit 0 again at 360, but notice I'm not being asked for I'm not being asked for going past 180 degrees. So, okay, so that's the first answer. Now the other answer happens when the sine of x minus 1 is 0. This factor could be 0. So the sine of x is 1. Okay, whereas sine 1? Sine is 1 here at 90 degrees. And again, I'm supposed to stop when I hit 180. So that's the only other answer. So that x is equal to 90 degrees. So therefore, I can put them all together. X is 0 degrees, 90 degrees, and 180 degrees. No, you don't have to actually stop and put them all in order. But it is nice and neat and organized to do that. Okay, this one is a difference of squares. So I am going to actually factor that. Now you might be wondering, why don't you just move the 1 to the other side and then square root both sides? Well, I could, but I think I'm going to like factoring it better. It's a little better organized on my page. So difference of squares simplifies or factors to conjugate pairs. So that means the tangent of theta is equal to -1, or the tangent of theta is equal to +1. Okay, where do those things happen? Now I'm counting in radians, and I'm saying you can go from 0 to pi or 0 to -pi. So now I'm going to have to be really careful about this. I got to count in 2 directions. I might even want to do this on scrap paper so that I don't mess it up. So let's see. Here's my unit circle. All right, let's think about the tangent family. Where do we know tangent is 1? Tangent is 1 at pi by 4, because remember the coordinates there are √2/2 and √2/2. And when you divide a number by itself, you get 1. And remember, tangent of an angle is y over x. So this y divided by this x makes 1. So tangent is 1 here at pi by 4. Where else is tangent positive? Not till I'm down here. So that would be the next place. So that's 1, 2, 3, 4, 5 pi by 4. But problem, look at my domain again. The domain here says you have to go from -pi to pi. So in the positive side of that, that's 0 to pi. That would only be this answer. I wouldn't actually hit this one because this goes past pi. So the only positive answer I have for +1 here is that theta equals pi by 4. Do I, however, also have to worry about going from theta is 0 to -pi. So I have to start here. I'll use a different color. I'll use red. And I have to worry about going this direction. And from there to, that would be -pi if I'm counting backwards. And looks like, aha, I'll hit it again. But I don't call that 5 pi by 4 when I'm going this way. I'd call it -1 pi by 4, -2 pi by 4. This would be -3 pi by 4. Okay, so that's the answer here, -3 pi by 4. Okay. All right, where is tangent -1 now? I have to answer this side. So tangent's -1 over here, which is 1, 2, 3 pi by 4. So that's an answer. And then I stop again. Oops, I'm off the page, sorry. I stop again when I hit pi, so that's the only answer, even though there's another one down here. But this one down here I will hit going in the negative direction. This, of course, is in the positive direction. This would be 7 pi by 4, but in the negative direction, this is -pi by 4. So there are my 4 answers. My 4 answers are theta is equal to plus or minus pi by 4, because there's this answer and this answer, and plus or minus 3 pi by 4 because of this answer and that answer. And there we go. Now they're going to give us a little break here. Here's one that's already in factored form for us. So all we have to do is just change the factors into answers. So 2 sine x plus 1 is equal to 0. So the sine of x is equal to -1/2, right? Because the 1 moves over and the 2 moves over. And the other answer is the sine of x is equal to √3/2, because that √3 would move to this side and then divide by 2. We're going from 0 to 2 pi. Okay, where do those two things happen? This one gave me a little more room, so let me draw my unit circle again. Okay, where do I get sine values of a half? Okay, sine is a half at 30 degrees, or sorry, we're in radians, at pi by 6, right? Because that's √3/2, 1/2. So sine is going to be a half at pi by 6. So when is sine -1/2? And I'm going from 0 to 2 pi. So starting here and going around once, how many times does sine get to be -1/2? It would happen here. Oh wait, sorry, not there. Sorry, sine's still positive there. My bad. Here, and it would happen again here. So this is 7 pi by 6. And if you're wondering how I did that so fast, I'm just going 1/6 past 1. And remember that 1 pi is equal to 6 over 6 pi. So add another sixth to that, and you get 7/6 of pi. So that's how I got that number. So there's my first answer. My second answer happens when I go all the way around and hit here. If I went another pi by 6, I'd be at 2 pi. And 2 is 12 over 6. So that's 11 pi by 6. So there's the two answers there. Then over for root 3 over 2, sine is root 3 over 2 at the pi by 3 family. Sorry, I'm writing so small. So there's that answer, right? And okay, that's going to happen in quadrant 1 at actual pi by 3. Where else is sine positive? Well, sine's positive here, so that would be at 2 pi by 3. And there we go. There's my answers. Put them in order. That'd be pi by 3, 2 pi by 3, 7 pi by 6, 11 pi by 6. And again, I don't really care if you put them in order from smallest to biggest. I like to usually do that. Okay. Now's the point where I'd probably stop and say any questions, but of course I'm making a video, so you can't hear me right now. So feel free to message me if you watch this video and it's just not making sense to you. You want a little bit more explanation, I'd be happy to do a Teams meeting with you. But now we're going to move on to ones where we're going to need our calculator to help us. Okay, I got a couple of different calculators here. I know I've had people comment on my videos going, I'm having a hard time because my calculator is not the same kind as yours. So I'll try to kind of alternate between, I've got this kind of Sharp here, and I've got this Casio, and they both work quite differently. If anybody's rocking a graphing calculator or maybe just a really old-fashioned TI-30X or something, and you're really having a hard time with it, again, just message me. I'd be more than happy to walk you through how to get that done in your calculator. Okay, step 1. This to me is no different than saying x squared minus 5x minus 6 equals 0. I factor it by asking myself, I say self, what two numbers times to make negative 6 and add to make negative 5? That'll be negative 6 and plus 1. So now I'm doing it with tangents. So this is tangent of x plus 1 and tangent of x. I just switched the order, but it doesn't matter what order they're in. So there we go. We are nicely factored when we do that. Now, let's think about this. Tangent of x equals negative 1 is one solution, and the tangent of x is equal to 6 is the other solution. Now, tangent, remember, is the one of the three trig functions, sine, cos, tan, the primary trig functions, is the one that actually can go bigger than 1 and smaller than negative 1. If this was a cosine problem, this answer wouldn't even exist because you can't have an inverse cos of 6. Remember, cosine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and hypotenuse has to be the longest side. Sine is opposite over hypotenuse, sine has to be hypotenuse has to be the longest side. So sines and cosines can't equal more than 1. But tangents can. Tangents can go up to infinity, in fact. So I'm going to inverse tan 6. So now, on my calculator, do I want to be in degrees or radians? I want to be in degrees. So I've been playing with this calculator, doing all kinds of stuff. So first things first, check for degrees. And then go inverse tangent of 6. Ba-boom. That is 80.5 degrees. And does it say in here where to round? No, it doesn't say. So if it doesn't say, we don't really care. So I'll just round to, come back. There we go. I'll just round to one answer, or to maybe two decimal places. So 80.54 is what I'll say. 80.54 degrees. Okay, so that is, now remember, that's what we call our reference angle. You might remember that from grade 11. So now over here I'm going to, again, make myself a sketch. And I'm going to ask myself, I'm going to say self, where's tangent positive? Oh yeah, tangent's positive here and here. So an 80-degree reference angle, 80.54 to be more precise, is its own, remember, angles are their own reference angle, so the standard form angle is no different than the reference angle. So one answer will be 80.54. However, tangent's also positive down here, so if I put an 80.54 degree angle here, I'll get the same value of tangent of that angle being 6, but the standard form of that angle is from here to here, so I have to add 180 degrees to that, because remember, from here to here is 180, right? I'm supposed to go all the way up to 360, so I could keep going to here, but notice I won't hit a tangent being positive again if I keep going all the way around. So I'm going to 360, but those are the only two places where I would hit a tangent of some angle is 6. So add 180 to that, and as you can see, the answer is, or, well, I don't know, can you see that? There you go, 260.54, again, we'll say. And that should make sense. And you know, you can check to see if this answer is right. After all you have to do is, since that's my angle, if I take the tangent of that, I should get 6. So the tangent of that answer is 6. We're good. We're golden. Inverse tan of that answer is 80.5. Add 180, and there's my two answers for that. Now the other answers come from here, and that one I can do with my unit circle because again, we actually kind of already did this question. Where is tangent -1 again? Oh yeah, tangent's -1 at the 45 degree families here and here. Okay. Actually, oh, you know what? I just realized I didn't quite finish this question. I'm sorry. Let me go back for a second. I'm going positively to 360 degrees, but I also have to do to, oh, I thought this was a negative. Oh, this is not a negative. This is 180 to 360. So, actually, I'm only supposed to look for answers. Let me go to a red pen again. I'm only supposed to look for answers going around this way, starting here and ending here. So actually, one of these two answers is not really an answer. The one in quadrant 1 isn't in this domain. So out you go. Sorry about that. That's the only answer there for that one. I just realized, I don't know, I just looked at this and I thought I saw a negative there, but I did not. My eyes were deceiving me. So anyway, back to this guy. Where is tangent -1? Well, tangent's -1 in any 45 degree angle that's in a quadrant where tangent's negative, which is quadrants 2 and 4. But again, I'm only supposed to be looking for angles from 180 to 360. So this one I won't hit, but I will hit this one. So where is that? Well, that's 1 pi by 4, 2 pi by 4, 3 pi by 4, or sorry, 1, 2, 3, 4, 5, 6. That's 7 pi by 4s. And if you're having a hard time doing, oh, sorry, we're in degrees. What am I saying? We're not. So let's try that again. 45 degrees, 90, 135, 180, 225, 270, 315 degrees. And if you're having a hard time counting around in either pies or degrees, that just takes a little bit of practice. Use your unit circle and make sure that you know what you're doing there. So 315 and 260.54 are the two answers. I think if you watched Ms. Cox's video, she forgets that tangent can be more than 1, and she says that there's no solution for this, but as you can see, there totally is, and we checked it with our calculator. We know it's there. All right, a couple more. Sine squared x plus sine x minus 12 equals 0. We factor. What two numbers times to make 12 and add to make positive, or sorry, times to make -12 and add to make +1? Yep. You guessed it. 4 and -3. And now the sine of x is -4. The sine of x is +3. And you know what we do next? We say no solution, because again, sine and cosine values must be between 1 and -1. Inclusive. They can be 1 or -1, but they certainly can't be bigger or smaller. Okay? So, that one actually does have no solutions. This one, however, will. I know what you're thinking. You're thinking, well, it's the same thing. Yeah, but remember, cosecant is 1 over sine. So I'm actually not going to spend a whole lot of time factoring this. We already know how this factors, and I'm going to write down the wrong thing because, I don't know, for reasons. So the cosecant of x plus 4 times the cosecant of x minus 3 is equal to 0. So the cosecant of x is 4, and the cosecant of x is 3. Sorry, that should be negative 4 and 3. Thank you. And so now, remember that that is 1 over sine, so reciprocal both sides, and I get this, and I get this. And those two things have solutions. Are they on my unit circle? No. So I'm going to need a calculator. Let's use the other calculator to give fair time to the other calculator. Okay, so inverse sine. So again, step 1, make sure, what do I want to be in? Oh, I want to be in radians this time. So on this calculator, I think I go shift setup, and yeah, and then notice it says 3 is degrees, 4 is radians. There, I'm in radians now. I don't know if you can even see that on the camera, but there's a little R at the top above my thumbnail. And that's R for radians. If there was a D there for degrees. And of course, you can always just check before you do any fancy calculation. Pick something you know. If you were in degrees, the sine of 30 would be a half. Well, that ain't no half, so I must be in radians. Okay, and I can, yeah, wait a minute, something's wrong here. Sine of 30 is, oh yeah, that's right, radians, in radian measure. The sine of 30, think about how big 30 radians would be. That'd be spinning around the unit circle like 5 times. Okay, anyway, moving along. The inverse sine of, okay, remember how we do this. We actually drop the negative when we use our calculator to solve. I'm going to put a little note on that. To solve for a reference angle, don't calculate with the negative. And if you're wondering how come, well, because calculators are programmed funny when it comes to negatives for inverse sine, inverse cos, inverse tan. They very often will assume that you want a negative angle answer, and they'll just give you the closest negative angle answer, and that's not what you want. So what we'll do is we'll find the reference angle for a quarter, and then we'll just figure out, using our knowledge of how angles work, what that reference angle gives us for a standard form angle. Here, I'll show you what I mean. So we're going to do inverse sine of 1/4, which you can either just, this one opens a bracket for me, so 1 over 4 if you didn't know a quarter was 0.25, and then hit equals, and it's 0.25, I'll say 0.2527. So x is a reference angle, is 0.2527. Okay, now let's make a diagram, a sketch. Okay, remember cos, sorry, sine here has to be a negative. Sines are negatives here and here, right? So this 0.25, which is a fairly skinny angle, remember this would be actually, you know, from here, an angle from there to there or from there to there is pi, so that's 3. So 0.2 is like, you know, fairly skinny. Not that these diagrams have to be to any sort of scale, but it's always nice to sort of reflect reality when you can. And there we go, 0.2527. So now that I know that, how many radians is it from here to here? Because I'm supposed to go from 0 to 2 pi. So I'm going to hit that one, and I'm going to hit that one. How do I figure those out? Well, I'm going to figure out the first one by going, that would be pi plus that answer I just got. So I'm going to take that answer I got and add pi. And where is pi in this calculator? Oh yeah, it's way down there. Shift pi. That's why I like the other calculator. Pi has its own button. You don't have to go looking for it. So that's 3.39. So one of my answers is 3.3. I'll go to a couple decimal places. 3943. There, go to 4 decimal places. 394. Why am I reading without your help? 394, and then the 2 rounds up 3. Okay, now that's one answer. I'm going to minus that pi again, so that I start at my angle that I started with, 0.25268. And okay, now I got to figure out this one. Well, if I kept going, I'd hit 2 pi. So this is 2 pi minus that decimal. So 2 pi minus the answer I had a second ago, and that's 6.0305. So there's two of my answers. I'll box them. I still got a couple more to find, though. What about where the sine of x is a third? Well, basically repeat the process. Inverse sine of 1/3, and I get 0.3398. So I'm going to put that one over here, maybe. So where is sine positive? Sine is positive here, so 0.3398. Sine is positive over here. Nope, sine. Yeah, sine is positive over here. Sorry, C-A-S-T. Yeah, sine is positive over here. So 0.3398. So my other two answers will be, well, you are your own reference angle in quadrant 1, so 0.3398 goes there. And this one I'd get if I went pi minus that angle. So shift pi minus the answer I just had, 2.8018. And there we go. There's our 4 answers for that equation. And if you're ever not sure if you have it right, you can actually punch this through. Like, say I wanted to check that answer, you can check it in here with a calculator. Remember that there's no button on your calculator for cosecant, but that's just 1 over cos. So 1 over, that's not over, hang on, delete. 1, that's better. 1 over I'm going to have to open a bracket for this, the sine of the answer I just had. Close that bracket and close this bracket and squared. So there we go. That's that thing. Plus 1 over the sine again of that answer I just had, minus 12 should be 0, and it is. Okay, so a little bit of an advanced calculator technique there, but if you're good with your calculator, just like any piece of algebra where you solve something, you should be able to check your answer. Note, I don't know if any of them in the assignment do this to you, and I certainly won't do this to you on the test. Everything I'm going to give you factors, but remember, you did learn in grade 11 that you can solve for any quadratic that has a solution that's solvable, even if it isn't factorable, by breaking out the good old x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. It's on the formula sheet. And you know what's nice about this too is if you get stuck and you forget how to factor, or you just can't see what the factors are, that will give you the 2 answers, or whatever. Okay? All right, basically we have just a couple last pages here, and they really kind of add only one wrinkle to what we're doing. Like, for example, maybe before we get to that, why did we have 4 answers? Because, well, we were told to find the answers. We were told to find all of the places that x would solve this equation if x can be between 0 and 2 pi. So we found there was 2 places where sine was this number, and we hit 1 there and 1 there. And we found 2 places where sine was this number, where we hit 1 there and 1 there. But what if I unlimited this domain? What if I said, don't just go from 0 to 2 pi, keep spinning forever? You're probably thinking, well, yeah, great. Forever means you'll have infinite solutions. You'll have a solution. You'll have a solution when you hit it there, and then spin around, and there again, and there again. Basically, what's the point of that? You'd have infinite solutions. Yeah, but I want a way to be able to express every possible solution if I kept spinning forever. That is what we actually call general solutions. So if the domain is all the real numbers instead of some set from here to here, if it's all real numbers, then there's an infinite number of rotations on the unit circle that will give both a positive direction and a negative direction answer. To determine a general solution, find the solutions in one positive rotation, then use the concept of coterminal angles to write an expression that identifies all possible measures. There are different ways to request general solutions. They are, you can say solve over the domain of all real numbers. You can say solve for theta or solve for x, and then x is an element of reals, or theta is an element of reals. Or it'll just sometimes say find the general solution for this equation. So let's try it. First, let's do one kind of the old school way. Solve for the cotangent of theta is 1 over root 3. Well, that is the reciprocal of tangent. So where is tangent root 3? Okay, do you remember where tangent's root 3? Make myself a unit circle. Tangent is root 3 where the y value is the root 3. And the y value is the root 3 in the pi by 3 family. So that would be 1/2 comma root 3 over 2. So that'd be y over x, which is root 3 over 2 divided by 1 over 2. The 2's cancel, root 3's on top. Boom. Pi by 3 is one of the answers, but it's not the only answer, because from 0 to 2 pi I'm going to hit another place where it's going to work out, and that'd be down here, because both of those coordinates are negative. The negatives will cancel, and so the two answers are theta is pi by 3, and let's see, that's 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3. And my kitten is at my feet while I do my math. Hello. Hello, kitty. Okay, so that's my answers. Now, what if instead of this, it just said theta can be any real number you like? So, like it said here, we start with 1 rotation. And that's what I have up there already. I have 1 rotation. So, theta can be pi by 3, but then I would hit it when I go pi by 3, but then if I spun around and hit it again, that would be pi by 3 plus another 2 pi. And then I could spin around, which means I'd be plus 4 pi. And then it'd be plus 6 pi, plus 8 pi. Do you see what's going on here? It's basically going to be this added to every even number of pi's. And here's how I say that. What the heck language is that? Well, it's saying that theta is pi by 3 plus 2 times pi times any integer. Oh, notice that also means I can go backwards. Starting here, going this way, I would hit the same place after going 2 pi backwards, or 4 pi backwards, or 6 pi backwards. This k can be plus or minus 1, plus or minus 2, plus or minus 3. If this k is a 1, that's 2 pi's. If k is a 2, that's 4 pi's. If k is a 3, that's 6 pi's. So I always get an even number of pi's. So that is the general solution for this answer. I need to do the same thing for the other answer. And yes, you have to do them separately. You can't mush them into one answer. That's what we're looking for. Okay, let's try another one. Let's try another 2. Example 3. Solve for tangent of theta is -4 over the interval from 0 to 2 pi. So when is tangent -4? So again, find me the reference angle by doing the inverse tan of 4. So let's see, am I still in radians? I'll go back to this calculator because I actually kind of like it better. Am I still in radians? No, I am not. Radians. Inverse tangent of 4. 1.3258. Okay. Where are we? Well, tangent has to actually be negative. So I have a reference angle in the negative tangent zones of 1.3. So that's a fairly big angle, actually. Like, oh, it's probably bigger than that because, remember, from here to here is a pi, so that's a 3 point something. So 1.5-ish is there. So 1.3 is going to be like, whoa. And see, it's still not big enough, but good enough. From there to there is 1.3258. And down here would be another one where tangent's negative. So again, what reference angles? Remember, reference angles are always the closest x-axis, positive or negative, to wherever your terminal arm is. At least that's what they taught me in grade 11, or that's what they taught me to teach you in grade 11. So there's my 2 reference angles. So what are those angles in standard form? Well, one goes from here to here, and that would be basically pi minus what I got. So pi minus what I got, 1.8158. And remember, that's radians. You don't put a degree on it because it's not degrees. And the other answer would be if I started here and went all the way to there, and that would be 2 pi minus the number I had. So I'm going to go back and get the number I had again. So I'm going to take pi minus that answer. There we go. There's the 1.32 I started with. And now I want 2 pi minus that answer. So 2 pi minus that answer. And that's 4.9574. Did I write that number right? 4 point. Whoops. 2. 4.9574. Yay! There we go. 2 beautiful answers. But those are the answers if I start from 0 and I go around once. Because I'll hit that line and I'll hit that line. 1, 2. What if I could go around infinite times? Well, if I could go around infinite times, theta is, and you can use this fancy curvy bracket. Remember you saw this in piecewise functions back in grade 11? It shows that your answer for your function is going to be several different equations. Well, in this case, it's going to be several different rules. The first rule is it's this thing plus 2 pi k, where k is any integer, and it's this number plus 2 pi k, where k can be any integer. What if it was not radians? What if it was degrees? The only thing that would be different would be that would be 360. Cool. All right. Solve for the cosine of beta. Ooh, throwing Greek letters at you. Fancy. Solve for cosine of beta equals 0 over the interval from 0 to 360 degrees. So, all right. Where's cosine 0? Cosine 0 when x is 0, which happens at, we're in degrees now, 90 degrees and 270 degrees. So from 0 to 360, I'll hit that one and I'll hit that one. So my answers for beta are, and I just write my beta just like a B, just I add a little tail to it. But you could try to be fancy like that, beta. Go right ahead. Anyway, what was I saying? Oh yeah, beta is going to be 90 degrees and 270 degrees. But what if I wanted the general solution? Spin around to infinity, hit those 2 spots on the line there and as many times as you like. Spin to win, pretend it's the wheel of fortune and you're spinning. Well, the general solutions are beta equals 90 degrees plus 2, no, not 2 pi, we're in degrees. 360 degrees times k, where k can be any integer you like. Or we can do it as 270 degrees plus 360 degrees times some k, where k can be any integer you like. Now, there actually is a way that you can shortcut this answer, because you'll notice that if you spin around 180 degrees from 90, you'll hit 270. I'll leave that to you. Can you figure out a shorter way to say all this? And if you can, great, but this is a perfectly good answer too. So that takes us actually to the end of the booklet. You are now ready to try the 4.4 assignment here on the last page. It's easily the toughest of the assignments. It's easily the toughest thing we've done in this course so far. So we'll give you a couple days to kind of try that before I actually have a review to hand out for you for Chapter 4, and then we'll start assessing it. We're going to do a Chapter 4 test. Cool. Thanks for watching.